Good morning to anybody on the East Coast. Really good morning for anybody that is on the West Coast of the US. And I guess good afternoon or good evening for those of you throughout the rest of the globe. Today's kind of workshop session is around the kind of use of generative AI in the surrounding tool ecosystem, particularly focused on R. We might talk a little bit about other languages, but especially given that this is R in pharma, we will kind of go through this. We have a number of exercises prepared, but ultimately, to an extent, this is a bit of an open, fluid workshop. All the material that we go through, all of the kind of code that I write live, we will put up on GitHub so you have access to it later and can kind of play with it on your own time. The goal, though, ultimately for me is to try to kind of blend together in this couple hours a combination of demystifying some of the options and capabilities that exist in the landscape today, which, even if you were up to date 3 months ago or 6 months ago, especially, already there has been so much new stuff consistently coming out that we want to give people an opportunity to kind of understand what they have access to and try to address some of the questions where there is almost a degree of potential decision paralysis around, like, well, should I use Positron? Should I use VS Code and Copilot? And there's Claude Code and there's Gemini and there's Codex. There's so many ways to solve this problem. Like, I don't want to make the wrong choice or something. Now, some people's choices are somewhat made for them by their enterprise. And even with that, there's this kind of FOMO, this fear of missing out, of kind of wondering, well, what if I had access to other tools? And so the goal here is hopefully to kind of prove out that there are many ways to get to a solution. And while we're going through that, my hope is that I can help demystify some of how things work. I think one of the observations that we've been making while we've been doing training sessions or workshops or kind of interacting with data scientists or software developers or other folks is that people's mental models of how these tools all kind of fit together and how they work is definitely a little bit leaky. And tightening up those mental models, kind of helping understand how those things fit together, can be really powerful to be able to understand essentially, like, why and when an AI is going to perform well and why and when it's going to kind of perform poorly. And so, again, hopefully by the end of this, you feel a little bit more equipped to be able to kind of address questions like, hey, what would it take to build a bot that could help with CSR, the clinical study report writing? Or, could we do something with our knowledge base? Or could we build a code review thing? Hopefully coming out of this, you're going to see some of the areas that you can get a lot of traction and capabilities pretty quickly, and some of the areas that these large language models break down, particularly where they break down in a way that looks right, but actually on closer introspection does not look so great. So as we are going into this, I have the chat window kind of open. And also we have Aathira and Xu Fei, two of the other engineers at A2AI that will be monitoring the chat. They will be kind of live answering questions that you have. So if you have a longer form question that might not be something that you'd want to bother me as the speaker with, that's okay. Still, please send it in the chat. They'll be typing along and addressing some general questions, and then I'll be kind of keeping a half eye and trying to call out and talk through any of the things that I can. And so with that, and to kind of test folks' chat windows, my first request to everyone is, if you don't mind typing in the chat around your level of experience and understanding for using using generative AI. So, for example, I have used GitHub Copilot. I have used Positron. I have built a thing with Elmer. I have no clue. I'm just coming in here because I'm interested to understand and see what can go on. Like if people can chat in there, this is super important for me also because I want to kind of meet the speed and the language to who is listening in. And so if I get a bunch of people that say I'm an absolute beginner, we can go nice and slow. If we get a bunch of people that say, hey, I've been already building a number of things, then we can kind of speed things up a little bit. And so I want to kind of meet somewhere in the where the goal for these types of open-ended workshops is to kind of be in the middle to the lower quadrant to make sure that we're not losing too many people. And so I already see a number of folks are like absolute beginners to the space. And so that's fantastic. That's what I'm kind of expecting. And so hopefully this will be a nice educative session for all of you. I'm just kind of watching a couple folks more. Okay, great. So what I'm going to do is I'm going to share my screen. Boom. All right. Can folks confirm that they can see my AI workshop experiments positron window? Zoom chat back. All right. All right, I got at least one thumbs up. Can see. Fantastic. Okay. So let's jump right in. So this is Positron. If you haven't seen it, I think many people have at least seen it from blog announcements or otherwise. This is Posit's new IDE, and it is a kind of a fork of VS Code that has a bunch of data science components kind of baked in and more natively available. And so ultimately, much of what I show, if you don't have Positron yet and you're using VS Code, a lot of these things are highly aligned. I'm going to use Positron Assistant for going through this so people can both see how Positron Assistant works, but also call out that if you don't have Positron Assistant yet, this is very, very similar to GitHub Copilot. And we'll shortly show that even other tools like Claude Code or whatnot, the patterns, the things that you're kind of working with are very thematically consistent. Okay, so the exercise that I want to start with and go through is to kind of orient you to Positron a little bit. I'm going to zoom in a little bit here. Let's orient you to Positron a little bit, talk through the kind of pieces here, and then jump in to an exercise where we're going to try to start to address questions that historically would be something done by hand. In particular, let me actually kind of introduce the problem space that we want to try to solve against. And that is to say, talking about package management is quite the hot topic, and understanding which packages are available, when they've been updated, which versions are around is something that often comes into the mix when you yourself are trying to kind of figure out what to do, and can be tucked into a lot of projects around like how as an organization do you assess packages or something like that. And so one source of data for that is, of course, CRAN, the website itself. So if we just pull up CRAN, we can see that you can go search a package on CRAN. It has information around the package, some of its information like its dependencies and whatnot. And also one of the elements that is very much called out on CRAN is the other packages on CRAN that rely on a given package. So these reverse dependencies are packages that use a given dependency. So like the BTW package uses Elmer. So this is a bunch of information that exists on CRAN, and like today with no large language models or anything like that, the kind of situation that you might find yourself in is you're going to go do what I just did. I'm going to Google the package in CRAN or something like that. I'm going to pull this information up. Enter in our new agentic situation where now I'm sitting here in Positron and I have the same question. Okay, I want to try to use this Elmer package. I want to do something. I have some questions about it. And the first question that I want to know is, which version is available on CRAN? And maybe when was it released? And so a chat window that people are reasonably familiar with, if you've used ChatGPT or Claude, what version of Elmer is on CRAN? And when was it released? All right, so we see some stuff pop up here. Now, what this is gonna, if you've ever used just like Claude, the kind of Claude application or ChatGPT, the first thing that you're gonna notice right here that's a little bit different when you're in these types of chat interfaces is this, this little tool icon here and then this prompt window. The idea behind these agentic kind of chat applications is that they have access to certain tools that are, we'll call available on the system, some of which are built in, some of which you can actually kind of bring yourself and present and say, hey, you have access to this. When it wants to start to use these tools, you can hit allow. Or you can deny, and you can also do things like you can allow one time or you can always allow. In this case, I'll say always allow fetching web page. And so, so what we also see here is that the concept of CRAN and the fact that it could figure out this website is one of those like bits of the magical knowledge that the large language model has of like it knows or it has in its kind of corpus of information in its neural network, the fact that CRAN is located at cran.rproject.org. And then there is this kind of like URL of web packages Elmer. If it didn't, it might get stuck and say, I need to do some more search, some other way of figuring out even where to go. So we can see here that it goes out and it fetches. And then actually what happens is it found this, and then it started hunting because it could not figure out exactly when the release date was from the first page. So if we kind of go back here, right, you see the version. Now, it did miss the fact that this was published on 2025-0903. And so it started doing some more hunting. It ended up kind of hunting into the archive, hunted some more, and then eventually it kind of stepped back and it said it was released on September 4th. Now, interestingly, what you can see here is that there is a September 3rd here. We go to this archive here. You see no information around September 4th. And so if we kind of walk our way back here, we're already presented with this kind of interesting situation of how the heck did it come up with the date of September 4th? Let me ask another question. How did you come up with that date? How did you come up with that? Right. So now what we're seeing here is that it's starting to backtrack on its response a little bit. And it's kind of walking away and saying, oh, well, actually, I'm not completely certain when this came. And so I don't actually have this thing. Let's ask it one more question. When was the package published? And so even though we see this published here, it is really struggling to give an answer here. Now, one of the things that I'm using here is I am using the Claude Haiku 4.5 model. So this is one of the Anthropic models that is faster. It's a little bit less expensive, but it's also not necessarily as intelligent. And so I want to take this same line of inquiry. So I'm going to grab this. And I'm going to start a new chat. I'm going to explain a little bit more of why I want a new chat. I'm going to switch this to Claude Sonnet 4.5, and I'm going to ask the same question. Now, interestingly, what we see here is a completely different approach. We see that instead of going and fetching out from CRAN on the web, this actually has decided that it wants to run a script that calls available packages and slurps up this information this way. It attempts to do it. This code doesn't work. It's going to attempt again, right? We can actually see it kind of dumping out some information. It's still struggling a little bit. And we're now seeing it in this loop of like attempting to figure out how to solve this problem. Now, you can nudge it sometimes, and you can say like, do a web search on CRAN. And now we get to instead see this kind of start to work through. Okay. Now it actually goes out to the web. It's starting to hunt for more information, continuing to make more requests. And hey, look at that. It eventually got, by switching and starting to use curl as well, it eventually got, hey, it was published on September 3rd, 2025. Now, what I want you to take away from this is a couple things. There are different models that are available to you in the broad ecosystem. This is not just a positron thing. This is kind of a general commentary on the fact that there are multiple models. These models have different personalities is the easiest way for me to describe it. So not only do they have kind of different amounts of information that went into their training data set, different dates that their training cutoffs may have been, the kind of corpus of information that went into the model was stopped. This can be different like within a given company. So like, Anthropic has Sonnet 4, Sonnet 4.5, Claude Haiku 4.5. All of these came from Anthropic. And so you can reasonably assume that the training data used for all of these models is reasonably consistent. Compare that to the GPT models coming out of OpenAI. They have likely a different approach to doing training. But ultimately, the blanket statement that I can make is the model personalities are showing up more and more in these agentic cases, not only in terms of how well they distill information, which has been a kind of common talking point for a while, right? More powerful models do better at data synthesis, but actually the models themselves will use things like tools differently. And they not only will they take different starting approaches in terms of how they start to kind of work into a solution, but when they start to get boxed into a corner where it's not working, if you use these different models, you're going to observe that they will take absolutely different approaches to trying to solve this problem. I'll do one more just to kind of prove this point a little bit further likely. I'm going to switch to GPT-5. I'm going to fire this off. Now you're seeing that this working is going to take a bit longer, right? In this case, for GPT-5, it's a more powerful model, but it's a little bit slower. You can see it's doing some fetching. It's actually doing some thinking, where it's actually saying like this additional information is it saying, hey, I am continuing to think about this. I'm continuing to hunt for this. It's even providing some of its reasoning information, right? These pages include publication. So I'll go ahead and fetch that. And then it gets in one shot, so to speak, the version and the release date. 3 different models, same question, different ways they got to them. Now, looking at the comments, this 5 minutes is infinitely more expensive than a Google search. To an extent, yes. Also, to be fair, I'm trying to set this up from a reasonably simplistic scenario that that is indeed solvable by a Google search. However, if we kind of generalize the problem statement of depending on where this data exists and how clear it is where this data is, the difference between, like, we'll say a Google search attached to a human and this large language model is the potential for autonomy, right? So in this case, when I ask that question, like, I actually do know the answer of where to go get it from CRAN. And so, yes, I could go get that, grab that piece of information from the web search and kind of use it as I might want. However, the more open-ended this question set becomes, the more hunting that needs to happen, the more that you have an opportunity to delegate that investigation. But as you're seeing here kind of live, the capacity for this to delegate effectively and to work well can be dependent on a number of factors. And so coming into the code itself, so the next kind of portion of this that I want to talk about is, as we just saw here, this did not work terribly effectively. But it did get to the answer. GPT-5 did it in one shot. These other ones took a little bit longer, but they eventually got there. And to some extent, if you are firing this chat off and going and doing other work, even if it takes a couple minutes versus virtually instantaneous, it's not necessarily that big of a deal. You might not be blocked while you're waiting for that information. Also, if you can figure out some way of getting this to be consistent, you might do this in a way that is truly autonomous, right? Where you're saying, I need to go do this, where I need to collect information about hundreds or thousands of packages, where I'm not going to go do those Google searches myself necessarily. I want to delegate to an application to do that. And so that's actually what I want to show now, is to say, what if we wanted to do this, and we wanted to do this in a way that we had this more constrained set of questions that we wanted to get at, but we recognized that there was some reason in our organization that this information needed to be collected and kind of collected consistently and collected over time. And there's a lot of momentum in organizations right now to say, is this something that could be solved by large language models? My hope is that the reaction to seeing even this in this kind of chat window is that these generalized agents can be very flexible and can attempt to solve problems in open-ended ways. But once if you have a task especially if you have a degree of structured data, it is more likely to wander a little bit than is ideal. And not only can it wander, as we saw from the first chat, I kind of go back to this one, right? The chat, the answer can straight up be wrong. Now, September 3rd versus September 4th might not be, in this case, something that mega impacts you, but this is a signal towards the kind of question of how much can you trust outputs from these. I want to show an example connected to that emphasizes this even further. I'm going to make another chat window, and I'm going to say, how many reverse dependencies does Elmer have on Cran? So we're using this powerful model that we, may have developed a little bit more experience against, and said, hey, this can work effectively. And while it pulls up this information, kind of let's compare and contrast this by hand, right? So these are the reverse dependencies that we're hoping that kind of scrapes off of the website. And presents back to us. Working. You can actually see its thought process as it's going through. It's starting to actually write some code to attempt to solve this. And it ultimately comes out, still gathering. And we see that it has 11 reverse dependencies, 22 total. Great. Now, I want to switch back over to Haiku, not GPT-5. And I'm going to ask, how many reverse dependencies does the dplyr package have? Now it's actually finding my tools, so I want to use a web search. Don't spoil the fun. Oh. See Peter's question. Peter, there are customized solutions to Peter asks, I work in pharma. Is it possible to use internal generative AI instead of Copilot or Claude and Positron? The answer to that is not today. This will eventually be a capability that is provided. In particular, one of the Posit's design goals is to make it such that you can wire Positron up to kind of any target that can route large language models. And so there's a number of projects like Light LLM. These are called gateways. And so these gateways enable you to an organization to deploy them and to kind of then abstract where the large language model provider is and still give you this type of experience. The other thing in general is you can also provide in this configure model providers, you can also provide, at least in this one, you see this just Anthropic or GitHub Copilot, but in the upcoming versions, you can also provide things like direct AWS Bedrock. And so, I think the question about internal, if I break that out into kind of two statements, one, some people ask, like, can I literally self-host large language models? Like, I have a GPU, I want to point at it. Like, the answer is kind of yes, but most organizations are not going that way because it's can be quite expensive from a capital cost perspective to kind of purchase the GPUs. For example, running these large, powerful models, the open source versions of them, like you're going to be looking at potentially hundreds of thousands of dollars of like GPU purchasing upfront to run the most powerful. Now, there are smaller ones that you can also run. And so for most pharma companies that we're interacting with, they are using like Azure OpenAI service if they're on Azure, they're using Bedrock if they're on AWS, or they're using, they're kind of qualifying things like GitHub Copilot, where Microsoft, kind of owning GitHub these days, is making commentary around, they're kind of putting SLAs, service level agreements around saying like, we won't store your data, we won't track your data, we won't do anything against your data. And so many organizations, we're working with a number of the kind of like top 10 pharmas and downwards, and many of them have already qualified, for example, GitHub, and said, yes, it is safe to use from an information security perspective. So if your organization is stuck, you don't have access to any of these tools now, hopefully this is something that there is more and more kind of cross-pollination and cross-talk across companies of saying, yes, more and more folks are getting access through one of these providers. And Positron either already has access through things like Copilot, and Anthropic and Bedrock are kind of coming along and will be available shortly. Let's see. So this demo is kind of, it is running a completely different direction than the kind of starting dress rehearsals that we did. So let me see if I can actually pull up an old chat that does kind of showcase what I was trying to. There we go. All right, so here's a chat, and like, kind of leaning into this as a conversational example around these agents. Like, I don't want you to get the impression of like, holy smokes, like this is crazy how different it is. It is. Like, you have to lean into the non-deterministic behavior that kind of comes in. Very small differences in how you ask questions, differences in how you expose tools and otherwise are going to get you different behavior. However, with a little bit of kind of experience in how you frame questions and how you present things like tools, you can actually control this experience pretty effectively. And so, the takeaway you should be here, if anything, is these very quick questions that I'm asking, right? Kind of we'll call it prompt engineering 101 has been, don't be so open-ended, be specific. And this is like, you're seeing this live. Now, what we're going to see here is that when we ask the reverse dependencies for dplyr, it goes and fetches dplyr, and like it can't even get an answer because there's just so much information on this page. And so it just says like, I can't even answer you. There are so many reverse dependencies. I can't even solve this problem. And if we kind of look here on dplyr, the reason is because dplyr is extremely popular. And you can see from a reverse dependencies perspective, I can scroll. So there's like a lot of. So our goal now, how do we make this consistent? Right. So again, generalize this in your brain into this can be applied across many data synthesis scenarios, but we're going to use this kind of package scenario as one for purposes of this exercise. Our goal here is to leverage large language models effectively to be able to distill this information such that when I ask questions, I get good, consistent results. So the way you do this, one way, as I mentioned, is you can start to be more particular around how you prompt, right? You can build a much more explicit set of instructions. That is going to be one of the pieces of guidance that when it comes to using large language models, the more explicit you are, the more you can kind of control the behavior. So you could do something like search here on, search cran R project, get the index, like you can kind of tell it what to do, and then you can let it do the kind of last mile work. However, the kind of commentary that I want to kind of call out is essentially to say, to be successful, especially to take advantage of these new kind of agentic styles of working, the most harmonious, the most effective way to use these tools is to augment the large language model with traditional software engineering, such that you can lean on to the large language model's capacity to kind of orchestrate and synthesize information. But as much as possible, when it comes to the actual extraction of information and the kind of consolidation and the parsing of that information, if you can make that deterministic, you can have a lot more confidence that what you are doing and the questions that you ask are going to be. And so this this brings me to our first bit of code to look at. Again, we're not going to go through this code in detail for the sake of time, but this will be completely available for you all to kind of look through. The idea here was to say, okay, if this is a query that we want to be able to build some tooling around to consistently do this across the organization now and into the future, what we want to start with is we want to start with taking this data that we have and processing it so that we have a much more structured representation that we can interact with. And so in this case, what we have here is we have a number of helper functions that are built around going and fetching. Here, let's take a look from here, right? We're going to go say, given a package, we're going to go get its index. Then we're going to read the HTML. Let's kind of go to this area of what does read HTML do? HTML. This is the built-in RVEST function. So it's going to process this page, and then it's going to start to extract information out of it. Right? I'm going to pull out information and start to parse this information out. We can extract the metadata from this, and ultimately build up this much more structured list of information. This is where there is an interesting union between you building better tools with AI to make AI more effective, right? So all of this code here, if this is something that you're looking at saying like, I don't have time to write this, like, yeah, probably as part of your job, if this was something that you looked at, it would become a little bit of a mini project, right? I need to go write an HTML scraper that scrapes all of this information and destructures it and kind of works through this. This would be something that, might take some potential days or maybe weeks, depending on your understanding of how web scraping and whatnot works. This is something that can collapse down into a very brief set of work. And so let me show you how I approached this, right? I want you to use the RVEST package to start to scrape this from CRAN. I want to extract this information, so I'm going to give it an example and the reverse dependency. First, I want you to investigate the structure, create some helper functions, and then eventually we're going to build some tooling on top of it. So it goes out. And what you're going to see here in this chat is it starts to write code, right? It starts to extract some information, and it starts to actually dump out. This is the old version of the package, the file, but it starts to actually write out this file, and it starts to actually kind of test it a little. And so for the most part, the vast majority of this code was written in maybe 5 minutes. So this can become intoxicating, right? You get all of this code that gets dumped out. 5 minutes later, like, ta-da, I have some code. So you've gone from this task that might have taken days or maybe weeks, or you never would have had time to do it, to suddenly something that takes 5 minutes. And so what I'm gonna, if you've not used this type of tooling before, I am going to beg you, please, do not take that time savings and try to just like be like, and now this task only takes 5 minutes. The time that you have saved, use some additional piece of that time to also build a degree of robustness around this to make sure it works. In particular, what I mean by that in this case is like, get some tests, right? This is a talking point for, when you're writing packages. This is another area that large language models can be very effective with, right? So, now I have some code. Let's actually write some tests against this code. And so, hey, given this sample HTML, can we extract the names out where if there was a bit of code that looked like this, we should get out chatter, chores, amend these, right? Test the dependency parsing, make sure that this information is extracted out. These tests serve multiple purposes when it comes to large language. One of the first things they do is tests in general are a fantastic form of documentation, right? Looking at the parse dependencies code, and you start to stare at this and say, okay, I'm trying to mentally reason, what is this going to return? How does it work? Well, if you have test cases that talk about this, right, I expect that this result is going to have a vector of packages that looks like this. I'm going to expect that, it's going to have a version spec, and the second one is going to be this. Oh, okay, like I can see how this connects together. Oh, what happens if it doesn't have a version spec? Well, look at that. Expect that it's NA. Okay, so it's going to be either NAs or values. Tests become a way that you as a human being can, check that you're going to get data that you would expect out. What tests also do is they can help govern the large language model. And the more tests you have, the longer and more effectively it can sit in this loop of it working in a way that it doesn't start to just either hallucinate or go down improper code paths that you get to be the benefactor or not of determining if this code actually behaves as intended. Tests for large language models become more effective as you have some of them in place. So in the case of having some of these here, the large language models will fall into a pattern of using patterns that they see throughout the code base. At least that's the kind of natural behavior that we've seen. And so if you are starting to add some tests, as you ask it to like, hey, I want to change the parser, I want to do this, I want to do that, please update the tests while at it. Like, it will work on both writing code, updating, or adding more tests as they go. Okay. So this is an activity that, again, can be generated in a fraction of time that it would take you to write these by hand. My second tip, though, while you are using these, while you are writing these, is it also can be something that people literally can review tests like this, like what I'm doing right now. I'm going to scroll real quick, like, okay, yep. Yep. Like, okay, looks good, right? This is a way to generate a bunch of, if you've ever heard of the term AI slop, where the large language models can have a tendency to sometimes write test cases that are kind of self-evident or can end up getting it such that the code gets tests that are passing, not because the behavior is correct, but because you can write a test in a way that you can get it to pass, even if it's not checking the right thing. So generate these tests, lean on the AI to help generate these, but go through them carefully. Think about them. Think about, like, is this test a good representation of what we would want to check and what the outcome that we would want from this is. If you're looking at a test and you're like, I don't know, like, I have no clue what this test is doing. It's not good. That is a signal to, like, you might need to think about this test a little bit. I wanted to show one of these tests. I left this in to give you an example here. So we wanted to have a helper function called get all reverse dependencies. And so let's kind of take a look at what this does, right? Get all reverse dependencies, gets the reverse dependencies, and then we extract the imports and suggests here, we get the combine, and we check to see that these match up. If I look at the code of get all reverse dependencies, it is literally the same code. So this is an example of, like, for all intents and purposes, a test that, at least for the complexity of what we're trying to extract out here, is a silly test. Now, this can become a not silly test if you start adding a bunch of conditional situations where this needs to handle edge cases and otherwise, where, like, but at the moment, this basically is a reconstruction of the 2 lines of code that exist here. And so these are the types of tests that I found that when we interact and ask the large language model to generate a bunch of tests, generate comprehensive tests, quote unquote, it will often, like, dump a bunch of these. And so you have this kind of process of curation and trimming some of them down and getting rid of them. Some of which you do by hand. You can try prompting and saying, reassess the tests that you just wrote. But I've found that it can often be worth, the extra half hour, the extra hour to really go through these tests carefully to maintain a degree of, kind of quality in your code base. So don't just keep running with the code as soon as it starts to output something. Like the way that I like to think about it is I almost treat interacting with the large language model as a game, where the idea is, like, what if you had somebody who their goal was to sneak in purposefully a couple bugs to see how well you can find them. And then the game for you is, do you catch all of the bugs that they add? Do you find them in your review? Silly exercise for humans to do, but, like, essentially when interacting with the large language models, that mentality of how you assess something, of what are you trying to do, where are you trying to trick me, can be a very healthy mentality to how you. So if we add this, I moved directory structures, so let me shift this around a little bit. Let's take a look now at what this code looks like. So I have an example here with Elmer, right? Fetch package info from Elmer. Fun fact, these are failing now. I can actually tell you why, because I've been keeping a very close eye on this. The BTW package came out. Package came out 2 days ago. I wrote this code more than 2 days ago. And so more than 2 days ago, there were only 10 reverse imports. And so my code here is actually saying, whoa, 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 whoa. I'm actually finding 11, not 10. So I didn't actually even think that this failure was going to occur, but let's show you how this type of thing can be fixed, potentially even with this interaction with large language models. So positron, what you can see here is that you see this little dot, dot, dot thingy. This is saying there's a couple things going on here. One is by hitting the plus sign, I am adding this file to the chat context. The other thing that you see here, this is very specific to positron, doesn't exist in like VS Code, is it's also able to actually see your R console session. So whether you want that, you want to see it to see what you've run or be able to inspect that or not, it's kind of up to you. In this case, I'm going to just hide this for the moment and say, I just got this error, right? I just got this error. In looking, I see there is a new package, BTW. So 11 is now correct. Please update the tests accordingly. And so it's off to the races. And this is what the experience looks like, where what it does is it's going to show you a diff of what it changed relative to what existed. So this is not like you don't have to use Git or anything like that for this experience. This is kind of like baked in where it is actually going to track in terms of these diffs, and it's going to present these diffs to you, and then you have the opportunity to keep them or reject them or undo them. And so this kind of very clearly can show where it's starting to make changes to the code. And this is, to me, much more representative of the magic of this experience, where if you can get into this comfortable loop where you're still doing some investigation, you're still doing some thinking potentially, but you're able to delegate these tasks, look at the diffs, accept them or guide them, kind of back them out, you can find a very nice pattern of interaction. So I've got that update. I rerun all this test again, these things, and we're getting there. One of the tests is passing. So, I still have one failing here, and that I'll look at Zach's question. All right, Zach. I would like to get a structured response from the large language model in text format, and then have another tool which can convert that text format into a response that can be rendered into a markdown table. It will come out a string with escape characters that need to be post-processed. So there's no mechanism to ensure that the table is corrupt. Yeah, good question, Zach. To kind of answer your question, it's somewhat of a loaded question, because the reason that this question is loaded is it depends on the set of tools that you're using to extract and combine information together. So it is those escape characters, like some tool in that sequence is generating those escape characters. And so what you need to do is you kind of need to find, like, the large language model is, I'm going to guess, unlikely to be generating this escape character. So you need to find which portion of the tool chain is adding those escape characters into the mix. And you either need to get those escape characters to be turned raw, which, again, depending on the tool, you can get those to come out raw, or you have to lean into that escape character construct and say, I need to have a tool that converts the escaped characters back to normal characters. And a lot of tools do this. In fact, like, just prove this out a little bit. Find, I think it's in bundle. Yeah, right. Like, even in, hopefully we'll have time to get to this exercise, but like, escaping XML, escaping HTML, escaping whatever is like super common in tools to protect the user. And so this is something that you're now fighting against, right? You're getting at AMP or at GT or at quote instead of one of these things. You need to, kind of either get that back or work with whatever that the tool calls are doing to say, hey, I don't want to escape. Some tools give you that capacity to actually say like do escape or don't escape. Because what can happen is if you don't do escapes and you like say that tool is going to pass it to HTML, you can run into situations where you can get all sorts of security problems. And so a lot of things sanitize that input through the pipeline. I know that's not a complete answer, but at least hopefully that gives you some background of why it's happening and may help you try to start to triangulate where it could be. Okay, so back to our parser. It's almost fixed up. We're getting close. Right, for the sake of time, we could iterate through this a little bit further. You can still look at tracebacks and see, oh, this was on line 118. In the test CRAN parser here. Scroll, 118. This is now 22. To kind of work through, maybe this will actually get everything. Test. Oh, still not complete there. There's more places that the test can fail. Right here, right, 22. We get it, great. We're in all tests passing again. Ta-da. Okay, now let's look at what this actually does, right? So this now prints a structured representation here of this output. And so the first step in building your own pipelines is often to start with starting to build out a set of tools that allow you to get bits and bobs of information, right? Get all reverse dependencies. Elmer gives me a vector of these, right? So inside of here, inside of this has a number of helper functions to kind of start to get at certain bits of information. And so now we get to the actual point of building a thing, right? So we've been interacting with positron. Good, bad, or ugly, you have this chat interface. It's something that you can use to interact with. It's not something you can necessarily stick in a CI/CD pipeline or an automated script or something like that. This is where we start to enter in this ecosystem of packages that allow you to interact with these large language APIs. And so the Elmer package is the kind of go-to package for R. And inside of Elmer, there are multiple different what are called providers, these chat providers, chat underscore. You can see here for that question about, how can I interact with large language models that my company will allow? Well, like hopefully one of these things, right? Bedrock, Azure OpenAI, Claude, DeepSeek, Gemini, Google, GitHub, like GitHub, and this is GitHub Copilot, like, right, if any of these are something that is provided, these are mostly cloud provided ones, but then you start to get into like Olama and Open Router, like the VLLM, these are ones that allow you to actually actually kind of even farm this off to kind of local. All right, so we use Bedrock at A2AI. We're kind of a mostly AWS shop, though, also do some Azure stuff. And so the idea behind a chat is a chat allows you to set up a chat. And look at that, it's already giving me some code completion from the context of my conversations in this. And so let's actually fire this question off and see what this chat answer gives us. How many dependencies does the package deploy? Now, what you're going to see here is you get a very fast response, but a very different response. As of my last knowledge update, dplyr has approximately this. I was updated in April 2024. If you want to get information, you got to go get it yourself. What's going on here? The key thing that's going on here is that when those tools that we were taking advantage of here that allow it to write code or look things up, like we don't have access to those anymore, or we don't have access by default, I should say. When we use this type of programmatic experience, this programmatic interface, you are starting from scratch, right? This is a blank slate of interaction with the raw APIs that allow you to engage with it. But you have to bring all the pieces that you care about. And so in this case, the thing that we care about is actually starting to take advantage of the tools that those functions that we've developed to get this to be a better answer. And so for the sake of time, I'm just going to kind of go grab a little bit of some of the solution space. I'm going to yoink this, and we're going to back over to here, show you what this does. All right. So tool is a function in Elmer that allows you to provide it a function and wrap it in a way that the large language model can interact with it. So in this case, right, I had this fetch package info dplyr. I have this function. It goes out and grabs all of that information from the web page and kind of parses it and sets it up. And so I want to be able to take advantage of this function, but I want the large language model to be able to say which package it is. So you give it the function, you give it a description. This is going to tell the large language model what this does, and so it can make a decision if it wants to invoke it. And then you also give it the argument list and the type of each argument. And this is going to allow the large language model to appropriately structure its interaction with our program in order to make this tool call happen. So the new version of this becomes, thank you for the Copilot code completions, chat, register tool. And then I'm going to ask the exact same question. So in this case, we now see that I asked the question, but now what prints out is a tool call. So the chat app has, in the chat, the large language model has identified that it has access to something that could help answer this information. And so to my question, how many dependencies does it have? It was able to extract this information and say, hey, you have 13 dependencies, right? As well as it depends on R3.5. So this intersection of providing it a more structured tool so we can ask this type of question, it can make a determination if it needs to invoke this tool. And when it invokes this tool, hopefully we give it a structure that enables it to answer a question effectively. Now, throw in the chat real quick. I'm gonna scroll up for a moment, right? Just to prove here. This does exist, so this is not like a trick question. Prints out reverse dependencies. It says imports 143, blah, 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 kind of mentions all of these. And then it should also have the suggest somewhere that says, yes, suggests right here, 4,306 packages. And then here's all of the packages that are the suggested packages, right? So the data is there coming from this tool. If I ask how many reverse dependencies does the dplyr package have? Is this, I'll ask it, what do people think the response is going to be? I'm going to give 2 minutes for people to type it in the chat. Give your approximate guess. Right, so I'm going to tell you the truth. The answer is here, right? There's 4,306 suggested packages. There's 143 reverse imported packages. So, you know, it should be something like 4,400 something packages is the true correct answer. 42, you know, the answer to everything. Anyone else want to take a shot? No. All right, let's fire it off and let's see what it gives. So 1,087 reverse dependencies, 1,041 packages that import, and 46 that suggest. How did you get that number? All right. Oh, I made an error. It's very apologetic. You know, it even gives up then, just as I can't even. This is an area that, again, I think that, like, I don't want to scare people too much, but I also want to showcase, like, this is a showcase of the limitation or the capacity for a large language model to do the type of requests that I think that people are expecting a large language model in isolation to be able to do successfully and consistently. You know, hey, I want it to extract a whole bunch of information from tables and do processing to insert that information into a clinical study report with very little intervention. People are, you know, does that exist? What is it going to take? Da, da, da. These are some of the types of questions that I understand why companies want this, but I want to, like, be very make very visible some of the limitations to large language models as basically these you know, prediction engines where they have these neural networks around how they kind of process these tokens of information and use this to synthesize a response is not something that can necessarily do computation in the way that you would expect. And it can be very, very misleading if you try this only on small information, where it is able to kind of process this information out in a structured way and then get to an answer, but then it doesn't scale effectively. As soon as you start giving it more information, it's scary because it doesn't necessarily get this. It still will give you an answer. And, you know, if you didn't look carefully and you had just looked and said, like, yep, looks like dplyr has a ton of dependencies. Great. I got a number out because my code didn't bomb. Therefore, we're good to go. So did not extract the textual information terribly well. And there's a couple reasons for that. The first reason is that, and one thing about interacting with the Elmer chat application is I tricked you all a little bit. Surprise. This imports 143 and suggests 4306 is a little bit of a red herring when it comes to the programmatic use of the Elmer package. And the reason for that is that if we actually look at how Elmer takes this information and provides it to the large language model, what we just interacted with was the print method, essentially, of the, go back to, I'm trying to find this get all dependencies. Maybe it's in the test. Ooh, here we go, right? The fetch package info, right? When we call this, this here was a print method, right? We attached this print method in order to kind of print this out in a way that a human can read it. But actually, if we look at the way that Elmer works, the way that these turns work, so let me call this again. Scroll up more, boom, here we go. All right, let's look at actually how the interaction with the large language model, how it occurred under the hood. Scroll up more. Here we go. Okay, so turns are the way that the large language model is engaged with through the API. And so the idea was the first turn, so to speak, so the first API request was made, this question was sent. Now, what happens is that in this case, the large language model does not returns an answer that is called a tool request. So instead of giving an answer, it says, you know what? You asked me both this question, and the thing that you don't see in this kind of print method is there's a question, and then there's another bit of information passed, which is, hey, here's the tools you have access to. So you have access to this fetch package info thing that could give you this information. And so the large language model says, ooh, that looks good. It extracted this part of the information, right? It needed this package dplyr. And so it said, excuse me, what I would like is I would like you to call fetch brand package info, please. So then Elmer invokes this code. And Elmer then makes a new request to the large language model. The new request includes all of this information, right? And this is an area that people don't always kind of connect together. Their expectation is a little bit more of like when you're having this chat engagement with the large language model, you kind of like send a chat message and then you send another one later or something. Like what's actually happening is it's an accumulation of information where the large language model itself has no memory. And so the concept of like a chat that goes back and forth like this is an artificial construct of the tool that we build, whether it be the like the positron assistant or your own kind of home rolled thing. This idea of being able to kind of like iteratively work, right? Like, oh, how did you get that number? Like when I sent this new chat request, it knew what I was talking about. Well, it knew that because actually this chat object is keeping track of all the pieces of the conversation. So the very first API request only has this information. The next one has all of this information, including now this tool result. And so this tool result, what we can actually see is it wasn't that print method, rather it was like raw JSON. It was taking this, I think it's approximately this. I'll use Elmer, right? It's basically collapsing that data and sending that over to the large language model. So that print method had this nice little parenthesis 143 and parenthesis 4036. Well, actually the large language model didn't even have access to that. It just had access to the raw values themselves. So understanding what this interaction looks like is key to be able to kind of build these things effectively. And thankfully, Elmer does expose a decent amount of this information pretty straightforwardly, right? Like you can get the turns to see all this information. You can, I think, get the tokens, see this. So this is showing how much information is passing forth. And what you can see with these user token counts is like it shoots up to 20,000 tokens. That's because of all that information that came from that dplyr inquiry. And then subsequently, every single one of these API requests has to send this information and the new information together, right? So when you think about the cost model of this, if you're using a raw API where you pay per token, you're not paying for like this many tokens and this many tokens. You're paying for the accumulated amount of tokens every single time. So it's like you paid for 20,000 here and then another 21,000 here and then another 21,000. So mentally, we want to think in those terms of like how a context window, this concept, excuse me, is called a context window, and this builds up over time. And every large language model has a limited context window that you have to stick with it. So if you start to have more complicated chats, an extension of this challenge is when you get past the context window. So kind of now for these Anthropic ones, it's about 250,000 tokens. You can get up to 1 million if you turn on certain API headers. Different models have different context windows. If you get to that or above, you have to start truncating some of the information that you can provide the large language. You can imagine that these tokens become more precious when you want to start to add more information to help get an answer. So in the case of these like chat applications that'll say like, oh, we have access to the entire organization's knowledge base, or we have access to every single drug submission, 9 million documents, or this, that, or the other thing. The answer is the large language model does not actually have access to this. You have to build tools on top of the large language model to be able to extract the relevant information you need and to fit it within this much narrower focus area of what you can ask. So a lot of the productionization and hardening of anything that interacts with these large language models is balancing how you find the information you need. Like how do you get it? Do you use tools like this to fetch information? Do you use things like RAG, this retrieval augmented generation, where it actually, before it even hits the large language model, the tool can kind of go in using some sort of similarity searches or otherwise extract some information and jam this in? There's a lot of ways to go collect information. But ultimately, this information very much must be distilled down such that only the information that is presented any given time is available to the large language. So Zach's question, if you have a complex query whose results you want to structure, is it better to make one query than attempt to structure it into a data structure, or start with the data structure and fill it using specific? Good question. Now, hopefully, I just teed up an answer to that a little bit with respect to if you have to make many specific queries, right? What you end up dealing with potentially is if you have this chat that like spans a whole bunch of like, add X, then like add Y to the response, add Z to the response kind of thing. What you're actually doing is like you're ending up sending all of that information and then asking it to like mostly regurgitate everything again, and then also expect it to like match in that little bit of extra information. It's a fantastic question. I think it's an area where like people's mental model of like that would be a very viable approach when it comes to like traditional tool development, where you're going to kind of like iterate in some loop and kind of augment and modify a data structure, where every single time you make a modification, if you design your code in a way that it doesn't touch any other portion of the application, you can feel very confident about that. But with a large language model, if you're asking it to like incrementally update something, you absolutely are running a risk, so to speak, that in the process of generating that entire token stream again, that as it's updating one portion, it may make modifications to the other portion. It doesn't like freeze that somehow, right? It has to regenerate that response every single time. So by the time you're actually getting towards the end, you have to build some very careful instruction sets to make sure it's only making modifications and like ask it to think hard and check things. And so, you know, in large parts, this is where, depending on the complexity of your query, first distilling down that query where you're extracting as much information as you need out of a larger body of information, structuring it, and then the question of, if you need to, like, say, build up a data structure, the question can be, how much of that data structure do you build purely in the large language model, or how much of that data structure can you actually build in your tool where the large language model can give you pieces of it, right? Question, extract this bit of information for me, where you yourself start to store the final output. Where in the process of these chats, as these chats are returning information to you, you can start to kind of connect that together. And you can do that actually through the chat structured, where you can actually govern the types of responses to not be so open-ended, but to rather say, like, I want this response to be a very particular structure that I can then like work off of. So, hey, only return this as JSON. And then if you need to distill a whole bunch of information, you can kind of fan out, get the bits of information, continue to return these different bits of like JSON, for example, or some data structure, and then jam them together in your actual tool to get you that final. For groups doing like complicated document processing or something like that, that's often the approach that's going to give you the most stability and kind of limit the blast radius of where a tool, where the large language model might introduce hallucinations, and kind of how you can start to mitigate that a bit. All right, so we don't have a solution for this yet. What do we do? Well, excuse me. The answer becomes, our goal is to write more specific tool calls in a way that enables us to present the types of options that we need in order to get the type of information we need. So I'm going to jump a couple, like I'm looking at the time, and I do want to at least cover this code review example as well some. So I'm going to skip a couple incremental build outs of this, and I'm going to go towards the end, and let's look through what a slightly more comprehensive version of this like new tool fetching capability is. Then we had that one tool, right? Get some information. Now what we're going to also add is some additional tool calls. And so let's kind of like take a look at, right? We've seen this one before, but now let's look at get dependency details. Whoop. I can source this. Now it's in rep. Details. Oh, is this right here? Go. So get dependency details now says, well, like, let me still call this function, but then I just want to return the dependency, right? Nothing else. So I'm going to just return the depends, the imports, and the suggests. Similarly, summarize package. So if I call summarize package dplyr, look at this one. This one likewise fetches the information, but instead of, like, for example, dumping all of the dependencies, it instead gives you just counts for the reverse dependency. So what we're doing is we're breaking out this original mega function into separate functions with a design of being considerate of how may these tools need to get invoked and what is the type of information you want to expose to the large language model, where the goal basically becomes to not overexpose information and to not expose information in a way that you may accidentally induce the large language model to take on challenges that it is not capable, aka doing things like counting thousands of packages, right? So in this case, summaries, you know, if we need any of those types of counts, give us this information. So we now have a suite of like 5 tools instead of just that one. This set all of them up. Let me just uncomment some of this stuff so we can and invoke it. Right. So we're going to build up our chat again. I'm going to register these tools. Info, summary, and perfect, dependency. Right, so now I ask the same question, right? It makes that first tool call, 35 dependencies. Notice it makes a different tool call, this summarize package. And so already we can see that it's giving us more expressive information for the same question because it's been given structured information in a way that it can better handle. Now, when I say better handle, you can also make an argument that like this is more verbose, right? Like I don't want it to tell me about the reverse dependencies. I just want it to tell me about the dependencies. This kind of comes into that kind of structured data conversation. But I'll kind of come back to that in a moment. But let's ask another question, right? How many reverse dependencies does it have? Notice it does not make another tool call. Why does it not make a tool call? It doesn't need to make a tool call because it has in its chat history that summary that had the information that it believed it needed in order to answer the question. So the invocation that it made was the summarize package, right? So if I look at this again, so the summarize package just gave the vector of package dependencies and then the counts for the rest of the things, right? Now, what it doesn't do though, right, what we saw in some of the previous chats was it was also saying things about version constraints. Well, you know, and for the sake of time, I had to shoot through this a little bit, but what we did is we distilled down some of that information, right? So like from the dependencies, I just ripped out just the names of the packages. I did not keep the entire data frame that had like the package and the version constraint. And again, the goal here was to say we want kind of like incremental exposure of information where you want to give just enough information to answer a question, and that might not be something that people always need. And so we want to let it have to go get that information some other way. And so in this case, let's now ask which dependencies have version constraints. And you can see here that it makes this now get dependency details calls. It recognizes that it needs to use this to get the answer and then gives us our full-blown answer with these constraints. And right, and so this information, not only are you getting good answers, but you're getting precise answers where you're much more resource efficient from a token perspective. So like, let's look at get tokens again. right? So that last time we did chats, as soon as I asked for this whole get package info, it used like 20,000 tokens immediately. So then 20,000 more on every single portion of that chat. In this case, we used almost 20 times less tokens. And that 20 times is like amplified every single time. And so from a cost perspective, this chat is something like, we did this 3 times, 4 times. This is something like 60 times less expensive than the first version of our chat. Now, granted, the 60 times less expensive, from a like a particular is like it cost I don't know, 10 cents versus 0.6 cents or something like that. But when you think about doing this kind of, we'll call it at scale, and by scale could be a lot of people using this tool, or it could be a lot of scenarios where it's just kind of sitting in this loop, really working hard on this. You can consume a huge amount of tokens depending on the tasks that you go give it. And so it can be the matter of hundreds of millions of tokens that can cost you tens or hundreds or even thousands of dollars versus pennies or dollars to get to the same spot, depending on how you build these tools. Let's see. Question: How Bruce is real quick. I'm just trying to ask here. I want a session to stay on track. Seeing all this and experience, how safe do you feel putting proprietary clinical systems data through an LLM? It's a good question. I can answer that pretty quickly. And then how do I get more familiar with Elmer? So getting more familiar with Elmer, the first thing is to go to the Elmer webpage and to go to the articles and to read these. Start with reading these. My second recommendation is don't spend too much time reading. You can spend a lot of time reading this, but you're going to learn the most from this by establishing and attempting to accomplish some objectives. First, like establish your objective. Your objective shouldn't necessarily be, I want to learn Elmer. It should be, I'm going to pick a problem that I want to use Elmer to help me solve, and then go look up the pieces of Elmer that are needed in order to kind of march your way through that. And that's going to expose conceptual gaps of, I can see the syntax, but I don't understand the behavior. Is this an Elmer thing? Is it a large language model thing? Like, it's going to start to open up how you actually accomplish this. But please don't just like go learn Elmer. Go pick a thing and then use Elmer to help you solve it. Bruce, your question. My take is that at this point in time, if you are comfortable putting your data in a cloud provider, if you're comfortable putting your clinical data in an S3 bucket or an Azure blob store or a solid state drive on AWS, you have the facility and the capacity to feed that data into a large language model hosted by one of those providers, because they're essentially providing the same degrees of SLAs around data that's going in. And so my personal take, and the take that as we've been engaging with organizations and helping them navigate this, has been that the much larger true risk of using these is the business decisions that get surrounded by the use of large language models. So my bigger concern around data flowing into the large language model is less around the data exposure, again, using a certain set of providers. It's more about, should that data have even hit a large language model in the first place? And what I mean by that is what we're seeing here is, right, that this large language model, the way that it was used most successfully is much of the data never actually goes to the large language model. The more data you feed it, the more likely you are to potentially get some funky information about data. So in this case, these tool calls that are helping distill and summarize a lot of that information, most of the raw data stays in process. Now, in this case, for the packages, yeah, the package names and stuff are coming here. But like, let's say you wanted to make a summary table for a clinical report. You don't want to be passing the raw data to a large language model to generate that summary table. You want the large language model invoking code that helps you build up that summary table where it's going to see, we'll call it the summarized data, and it's going to see some of the information about how it might invoke a tool call, but it shouldn't see much more than that. Because if you're putting much more data than that, you're really opening yourself up to a huge swath of hallucinations and other data quality problems that transcend security. Okay, so we've gotten to this situation. We've introduced the concepts of tool calling. Now, wouldn't it be nice if we could actually expose these tools not only to, so like I don't have to either make a decision of can I use Positron Assistant or can I use, like, do I have to use Elmer by hand? What if I want to use both? This is where the BTW package comes into play. This just hit CRAN 2 days ago. Very exciting to kind of have that stability, a degree of a stability declaration here. But I want to show you just how easy it is to wire this into Positron, right? So I just copy and pasted this tool setup that we just built. All I have to do is add this one line of code. Make an MCP server, a model context protocol server that has access to these tools. Then from I can add that to Positron by saying from my terminal, Positron add MCP and give it a name. You can also do this, I believe, through this, like this, I just clicked here. I know I'm clicking fast, but configure tools. And you see now that my CRAN packages MCP server has popped up. Now, I know this actually has a little bit of a slight issue. I need to do one little fix up here. Click. Needs my full paths, so give me 1 second. Where did I push you? Oh, here. All right, this is CWD. And this is, do this quickly for the sake of time to get this thing to work. See if that works. All right, so let's start this thing. See if it starts up properly. Yelling at me right now. Error. What is the issue? Cannot find file. Because I moved these around before starting this up. Right. All right, so this was now prep. All right, come back here. Settings. Start it. All right, it's running. All right, so now in here, I see this thing checked. This is now exposing this as an extra tool that my chat apps have access to. And I can say, how many reverse dependencies does the dplyr package have? Fingers crossed. It makes a tool call. And look at that. It's saying, hey, I noticed you have this fetch CRAN package info. And I'd like to run this with the package name dplyr. Now, this is the mega one right? This is the big one. So I'm actually going to say, no, please don't do that one. I'm going to say, use the summarize tool. So now it's saying, okay, I want to use the summarize package. I'll say yes, running, and it gives me my answer in one shot. Now, this is a deficiency of these descriptions in my mind are like, this is for the sake of, expediency. These were very short written descriptions. To do this well, to not run into these situations where it kind of picks the, potentially not as good tool or the wrong tool, is like these descriptions should be a little bit more comprehensive to help guide and allow it to make a decision around what it should use or not use. So for example, it could even be, sometimes it's saying what it does do and say like, do not use this tool for getting reverse dependency counts or something like that. You can tell it what to use it for and what to not use it for. But ultimately what you can see here is like this tool that we wrote is now exposed in a way that we can use this in this chat experience as well. And so my projection here is that in the same way that organizations have started to, build R packages that wrap up scripts, that wrap up capabilities that you want to provide through the organization, is that this is something that is going to become more and more prevalent as organizations are using AI in their day-to-day workflows, where it's not just going to be around the selection of the large language model that you use. It's going to be around how do you develop the right set of tools to enable your various workflows to be kind of precise and robust. So John asks, do understanding these tools consume tokens? They absolutely do. And so let's take a look here. We actually go into the chat debug view. We can actually see, right? So we just talked about to accomplish this here, raw, we used 1,000 tokens, right? Let's actually look at what Positron Assistant needs. You can see this right here. This uses 24,000 tokens just to start. Now, if you look at that and you say, holy smokes, why in the world does it take 20,000? The reason is because, and this is the case for when you're using Claude, like the Claude app or the ChatGPT app, there's a ton of surrounding information that is also like encapsulated in what's called the system prompt that you're kind of may not even be aware of. You can actually see this through this diagnostic plot. So this diagnostic kind of debug window. And so we can see that whenever you're using Positron, what is inserted inside of here is there is some metadata information. And then you start to actually see, so here are all of the tools, right? Here is the function, create directory, create file, create new workspace. Like there's a ton of tool information, including if we go all the way to the bottom, we should see ours. Somewhere in here is going to be our tool as well. Then you're going to see the system prompt, right? So this is the guidance that Positron Assistant is giving it. And so when we see some kind of different responses from Positron Assistant versus, say, our raw chat, some of this can come from the behavior, right? So the system prompt, you're an expert AI programming assistant. You want to be terse in your replies, but friendly and helpful. You should do this, you should do that. Your style should be this. If you're using R, you should use these things. This is all guidance that goes into every single inquiry that Positron makes to the large language model. The Positrons is something like 20,000 tokens, including the tool calls. If I remember correctly, something like ChatGPT or Claude's is something like 40,000. They have a ton of information that flows in here. So this is I suggest that if you're getting into this is a thing to read. It's a thing to read. I think the Posit team has done a really nice job of structuring a lot of information and giving you some good guidance around how to be effective with this. But also understanding what is in there can help you reflect, if you're building your own thing, what you should either co-opt yourself or what might be in here that might conflict with what you're trying to do. You know, if you're trying to get an answer in Positron Assistant, you're also needing to balance your user prompt against all of this other guidance. When you go here, when you use this chat, you start with a clean slate, right? Pros and cons associated with a clean slate. And so, right, there's a whole bunch of information, even how to do data transformations, all of this stuff makes it into a set of instructions that Positron passes along. Before, it also tells you about your, you know, the directory structure and whatnot, everything that's in the user's environment. So it sets you up with a lot of information to make Positron hopefully helpful, but also it consumes a portion of this. And sometimes this will come up when people are like, hey, you know, I wanted to add this thing and I did a token count on it and it said it only used, you know, 150,000 tokens. And they say that I have a 250,000 token context window. Why am I getting rejected with too many tokens? Well, it could very well be all the other stuff that gets attached by the time a response goes through. All right, we have about 10 minutes. I want to go to this other code review example, which I can kind of demo pretty quickly, but I want, before I even open this, because this is actually a nice frame for it, let me go back to that, that debug view. These are called XML tags. This is a technique used in order to help structure information for the large language model so that it can understand kind of boundaries that you would like to provide. And this is, again, kind of we'll call it a well-established technique if you start kind of reading in various blogs around how you can structure information to make the large language model more successful in delineating what's going on. So when we think about building effective tools and prompts ourselves, we want to lean into some of these types of patterns. And so this code review tool, this is we have a custom tool that we've written in Rust that does a whole bunch of stuff that we use kind of internally in the company. What I did is I kind of translated a portion of this into an R package that we can use with Elmer to kind of stimulate this concept of how can you build surgical tooling to be very precise in how you want it to behave so you can get higher quality answers potentially, as well as more deterministic answers. So for people that are, you know, worried around the quality of the answers coming out, the consistency of the answers coming out, you do have a lot of knobs that you can tune depending on how you prompt and provide guidance, and how you stitch together things like tool calls and structured information, structured data. So Jonathan, is there a GitHub link for the workshop files? Yes, we will post one and respond in like the LinkedIn area and a couple other areas for people to kind of find. And whenever the YouTube video comes out, we'll kind of post the link there too for folks to get access to all this code. Okay, so what does this code review thing do? So the construct, the thing that we found is GitHub Copilot reviews are getting better if you ever use them, or some of these code review tools. They are absolutely getting better, but at one point in time, they're pretty bad. They're pretty bad because they give you like very generalized code review guidance where it's like, you know, 1 out of 5 recommendations were good, but also like 4 out of 5 could be very noisy. And so what we wanted to do is kind of build out the capacity for both code review as well as for example, for scientists, things like code QC, which isn't necessarily a code review, but it could be saying, hey, we need to like check that certain institutional processes are enforced. So the goal was to say, could we build some tooling that would help enable that to be successful? So when we think about a code review or code QC or otherwise, you kind of have a couple elements that go into it. The first element is you obviously need the code in question that you want to review. You need some guidance. So this is where this system prompt comes into place. You know, what are you? How are you going to provide feedback? I have an extremely simple prompt for the sake of size and kind of demonstration. But usually this would be like, I don't want to say much longer, but like, you know, having some examples, having more structured guidance, you know, some thousands of tokens is still a good use of being precise in the type of guidance that you want to provide it. And so what we need to do is we want to stitch together that system prompt that we have, as well as some of the dynamic information that might be viable for this review. So in this case, what I have is I have this function collect content. And the idea behind this content, so I'm just going to run this real quick and let's shuffle things around. So this is now in rep, cran parser, and this is, I think, in rep, that's cran parser 2. Let's go grab this information. And let's take a look. So what collect content did is all it did under the hood is reasonably simple from this point, is it's going to collect each file that you give it. It also can collect globs. So you can do something like give me all of the R scripts kind of thing here. So if I run this one, it's going to actually give me a much larger set of content that has, you know, all of those chats and whatnot. So it's going to collect some content patterns. And then it's also going to collect in there. It's going to say, oh, right, lost this. Mm-hmm. It's going to collect some additional things, like it's saying this is a tag file, and is there any diff associated with this? And I'll show how this materializes in a moment. And then we have this helper function, bundle to XML. And so if we look at this bundle to XML, what this does is it automatically wraps up the files in those XML tags that I just mentioned. So in this case, it's saying, yep, there's this file here, and there is a path, rep cran parser v2, and it was of type R. This becomes critical to things like if you want to pass a bunch of code over to a large language model to assess, and it actually has to look at dependencies between files and whatnot, these types of XML structured tags can be critical for it to understand some of the other metadata that I might need to assess. So let's now run this through, we're going to take this bundle to XML and we're just going to feed it into the chat. Take my chat and I feed it in, and off to the races. I have a nice overview with some critical issues and this, major issues, minor issues, right? And then a summary of recommendations, and sillily sometimes. This is where we've collected the information. This is where you can spend a lot of time massaging this system prompt to get you the type of feedback and the feedback loop that you want. So in this case, for example, I could say like, just do something simple. Do not provide any time estimates. Only call out critical issues. So let's just make that little change, and I want to reprompt this and see what it pops out. So now it pops out the critical issues. And in this case, it now starts to dump out major issues. And then it starts to dump out minor issues. What the heck, right? In this case, this is a good example of it didn't do the time estimates, yay, but it did still kind of ignore me and print out minor issues. Do not print out minor or major issues, only critical ones. Our time is very important, and we can only look at critical things. But this might seem silly, but let's see what happens. We get our critical issues. And that's it. This is what I mean when we say prompt engineering or context engineering is so important to being able to build up the types of outputs that you care about. This is where, when it comes to, from a conversational perspective, you can also start to grow this a little bit further, where you could do something like chat, summarize the issues found into a markdown table, right? That was one of the asks earlier on. See how it does. Now we have our markdown table summarizing these things. So this whole pattern here could be wrapped into a wrapper function, if you will, called, like critical code review, where you could then take this information, you could take this information, you could put this into a Quarto document, you could have a table up front, like this idea of being able to start to destructure some of this information in a way that you can then kind of incrementally get the stuff that you want out of it is one of the things that makes this Elmer API actually very nice to set up this kind of like, they're called like prompt pipelines, where you can actually say, I'm going to work through, sometimes it is sequential, but you can also do kind of like parallel style things. Like one example that we can use is that if you give an LLM too many instructions, especially if they're potentially conflicting, it can get confused, right? We even saw here, just like only call out critical issues, like it did not understand that enough. So you have to start yelling at it a little bit more, right? The more and more information, the more guidance you provide it, the more likely it is to potentially miss something. And so one of the other techniques, for example, that is being used is where, and you'll hear this term of like sub-agents or experts or other things, where the idea is to say, what if we have these more isolated contexts where we're going to say, I'm going to feed the data that I ask, and I'm going to have one prompt that says like, only focus on these things. And then I'm going to have another prompt that says only focus on these things. And then another prompt that says only focus on these things. And then I'm going to take all of those responses and give it to yet another prompt that says, take all of the information from these experts, from these outputs, and come up with a final recommendation. And so this is where you can start to build a lot of precision in by building out different ways of orchestrating the large language model interactions to best leverage how you can set up large language be successful. And how you do that and how you build that and how you get that to kind of work consistently across a number of scenarios, I'll talk a little bit about in my talk this afternoon. But the kind of put that forward, the idea here is if you get into this and you're really starting to explore and say, I'm going to not only build these things, but I want to kind of continue to make sure that they're working well. This is where the concept of evals come in. So I want you to hear this term evals. And so so the inspect framework is a Python framework for doing evals that does a ton of stuff that you can go take a look at. The R equivalent, if that is, we'll call it a subset of the capabilities of inspect, but kind of tacks on to some of the capabilities, is the vitals package. And so the vitals package is actually using like Elmer under the hood to do a lot of these interactions. So hopefully I demystified a little bit of what you can do. And this is wrapping this up into these concepts of like tasks and solvers and scorers for how you can kind of get to a way ultimately of saying evals are about saying, I want to provide the large language model a number of scenarios one at a time. I want to provide a kind of ground truth answer of what a good answer would look like. And I also want to provide a kind of scoring rubric of what and how a good answer would look. So in the case of our example here, a scoring rubric would be, there are no major or minor issues present, right? And then you can try, for example, different styles of prompts and then feed it through the evaluation framework, where it is kind of a little wild, but that idea is like, it's going to collect the responses. It's going to use the response, the ground truth, and the scoring rubric, and it's going to feed that information to another large language model to kind of grade your output. And that can help you kind of get a pulse on how effective whatever you're building is actually working. And this in and of itself is a multi-hour conversation. So, I've just talked about evals in 3 minutes, but it's a very interesting area to explore and to appreciate how the broader community is addressing these problems. And one of the things that's nice for us, not being, we'll call it at the tip of the wave, is we're able to take on a lot of patterns that are establishing themselves as working well in other industries, where we can kind of adopt them into the pharma space. So for example, evals, there are a lot of companies that are well out in front because they've been using AI a lot more expansively. And so it's not that pharma has too many issues that are super, super unique to pharma when it comes to LLMs, right? Structuring data, synthesizing information, being conscientious of tool use and whatnot, and token counts and all that. Like, those are all general problems that exist everywhere. And so a lot of these eval frameworks are really have either solved or are actively solving a lot of those problems that we can kind of lean on those learnings and be able to jumpstart taking advantage of the discoveries the broader community has already been solving for a bit. Okay, the last thing that I just want to show in this recording so people can explore this a little bit more is one of the things that's very nifty around this code review thing. The thing that can make these code reviews effective are not just about collecting content, but collecting other stuff. And so in this case, for example, this idea of when you're calling things like collect content, not only can you collect the content itself, but you can also collect things like information about which files have changed between commits and what the diffs of those files were. And so essentially this collect content gives you a bunch of flags that you can use to say, like, include the git log, include the diffs of the files, include the full contents of the file itself, not just the diff. And you can play with that depending on what you're trying to get out of this information, to be able to build a set of information that you can then feed to the large language model. And so we found that For purposes of like code review and QC, you can actually build some very nice surgical tools to give you very high quality answers by determining which information you want to provide, combine that with some kind of organization specific guidance, and run with that. So hopefully this stimulates some ideas around how you might be able to dip your toes in the water, whether it be kind of data parsing or code review or otherwise. There's a lot of ways that you can either build the tools from scratch or integrate with things like Positron or Positron Assistant. It's a very exciting and heavily evolving space. And so my closing statement is going to be, if you feel like you're behind and you know that oh my gosh, everyone must be way ahead, like, don't feel that way. There are some people that are out in front, but many people are just still trying to get their jobs done day to day, and AI is a piece of enabling you to do that a little bit more effectively, and when the time is right, being able to adopt that will be great. But you're really like, the counterpoint I can make is basically by waiting, you've avoided a whole bunch of churn and are now coming into the most polished the ecosystem has ever been. And if you can't start using this for another couple months, it's going to be even more polished. And so take that bright side of, if you're not exploring yet, there's still plenty of time to get in without falling behind. And if you already are exploring, hopefully this gives you some new ideas of how you can continue to explore more fully with some of these new capabilities that are coming in. And so, thank you all for the the attention. And I'll pull up one last thing and then hand it over to Phil. This will pop up on our A2AI GitHub page later today, and you'll be able to kind of follow along these exercises. We also have some other LLM related tools that are kind of popping up. So, please come check us out, try the tools, have fun.
Fantastic. I was just going to say, Devin, if you have any links or resources, put those in the chat box. A few people have asked for them, but it sounds like the best thing to do is revisit your GitHub later today. And then when we post this online, we should have the info. I just wanted to thank everybody for coming. We're going to transition now over to the R and Pharma keynote presentation and starting talk at 10 a.m., which is going to be in 4 minutes from now. Just want to give everyone a quick heads up. We are going to post this video on YouTube. So if you follow our YouTube channel, R and Pharma, you'll get announcements when these videos go live. It usually takes about a month or so to get all the approvals and edits put in place. The credentials for the badges, we put the form in the chat. So if you missed that, feel free to grab it. Anna just put it back in the chat box for you, so you should be able to get that. We're running about a week behind on those, so if you don't get it right away, don't worry about that. I just wanted to thank the A2AI team again, Devin and the group, for a fantastic workshop and some really exciting ideas and topics around LLMs and pharma. We're going to have more LLM AI talks today on the program, so stay tuned. And with that, we'll go ahead and end the bridge today and kick people over into the actual keynote. So thanks again. Appreciate it for everyone joining. Lots of clapping hands in the chat box, Devin. So thanks so much.